Alright, let's look at the mass spring Dashpot system. Remember that when we talked about the mass spring Dashpot system, the equation became mx double prime plus cx prime plus kx is equal to f of t if there's any external force, and m being the mass, k being the spring constant, c is the Dashpot constant. Alright, so let's look at the free undamped motions where Dashpot is removed. Right, so free just means that there's no external force, so it's f of t in this case is 0, and undamped means that the Dashpot is removed, so c is going to be equal to 0. Right, so we have this equation mx double prime plus kx is equal to 0. Right, so let's try to solve this equation here. So we start with mx double prime plus kx is equal to 0. Right, and I'm going to divide through by m. Alright, so we're going to get x double prime plus k over m x equals 0. Right, so what I'm going to do is I'm going to rewrite this this guy right here, k over m. So this is just a constant, right? So I'm going to rewrite this guy as a square root of k over m and squared, and I'm going to let omega or w equals square root of k over m. So this is going to be omega squared. Right, so we can write this guy as x double prime plus omega squared x equals 0. Right, so maybe I should say this is where omega is equal to square root of k over m. Alright, so let's look at the characteristic equation. So the characteristic equation is going to look like this. R squared plus omega squared equal to 0. Alright, so you can see that this is going to be a complex root. So R is going to be equal to plus or minus omega I. Right? So we know that the solution is going to look like this. So I'm going to call it x of t. Right? Is going to be equal to it's going to be just a combination of cosine of omega t and a sine of omega t. So I'm going to write it as a cosine of omega t plus some constant b sine of omega t. All right? Then I'm going to manipulate a little bit so it makes it look a little bit different so that we can kind of see what's going on. All right. So I'm going to actually pull out square root of a squared plus b squared from both terms. All right. So what you get is going to be this. Alright, I'm going to leave cosine of omega t as it is. Alright, then times, so since square root of a squared plus b squared is factored out, so I'm going to have a over square root of a squared plus b squared. Right, and plus. Right, you have a sine of omega t, so this guy is left alone. And then we pull out the square root of a squared plus b squared. you're going to get b over square root of a squared plus b squared. Right? Then if you can see that, if you look at this right triangle here, I just drew a right triangle. So I'm going to put B here and A there. So B is going to be the opposite. A is going to be the adjacent. So using the Pythagorean theorem, hypotenuse would be square root of A squared plus B squared. And the angle is some angle alpha. Alright, then if you look at the A over square root of A squared plus B squared, that's just going to be adjacent over hypotenuse. So you can actually think of this guy as cosine of alpha. Alright? Then if you look at the b over square root of a squared plus b squared, that's just going to be an opposite over hypotenuse, which is going to be sine of alpha. Right? So what you get is actually cosine of omega t cosine of alpha plus sine of omega t times sine of alpha. Right? So if you look at this trig identity, if you remember, it's a cosine of x minus alpha is cosine of x times cosine of alpha minus sine of x. Oh, actually, this is going to be, I messed it up, so that's going to be a plus. Sine of x times cosine of alpha. So this guy actually fits exactly the form. So we can actually rewrite this guy as, right? And to make it look a little bit nicer, I'm going to call this guy C. So it's going to be C times cosine of omega t minus angle is alpha. Right? Then what we want to do is we want to make sure that the alpha is the angle between 0 and 2 pi. So this is what they're going to do. So here, where? Right, so how do we find alpha? So alpha is going to be equal to, alright, so depending on where it ends up, but it's going to have a different expression. So there are three cases, alright, if right, A is positive and B is positive. Alright, second case is if A is negative, right? And the third case is A is positive, but B is negative. Alright, so we want to find the angle, angle alpha, which is going to be between 0 and 2 pi. Alright, so what we want to do is this. So in order to find the angle theta, alpha, so what we do is, alright, so if you look at this triangle here, alright, when you look at the tangent of alpha, is going to be opposite over adjacent, so it's going to be B over A, right? So if you want to find alpha, all you have to do is take the arctangent of B over A, right? But you have to be a little bit careful because arctangent will only produce the number between negative pi over 2 to pi over 2. Right, so depending on where it ends up, but we have to actually adjust a little bit. Right, so first case is when A is positive, B is positive. Right, so what we have is that we end up, so A is positive, so maybe we should put that. So A is positive here. and B is also positive. All right, so we're talking about the angle, which looks kind of like this. So you have, and the angle is going to be angle there. So this is the angle we're talking about, right? So in this case, we can just take, arctangent of b over a will give you that, because this is going to be an angle between negative pi over 2 to positive pi over 2. So alpha is simply arctangent of b over a. All right? All right, the second case, if a is negative, right, so that means that a is going to be over here, right? And let's keep a b where it is. So then you have here. All right, so the angle we are interested in is going to be the angle here. So I'm going to have alpha is going to be from here to there. All right, so when you do arctangent of b over a in this case, so b over a is going to be a negative value. So arctangent is going to be a negative value, which is actually over here. If you look at it, arctangent is going to actually shows up over here. So this is going to be arctangent of b over a, right? Which is not the quite angle we want. So what we can do is we can actually add pi to get the angle that we want. So we have a second case, we take arctangent of b over a is going to give you a negative angle. So we're going to add pi to get the correct angle. All right. And the third case is going to be a is positive, but the b is negative. So what happens is so b is negative. So I'm going to just put the b down here. Then we are thinking of the angle, something like that. All right. Then again, it's the same kind of deal, and the angle is alpha that we want, this angle all the way around to here, right? So that will be our alpha that we want, but the arctangent is going to give you a negative value. So what we do is I'm going to add that 2 pi to get to the right angle. So you have arctangent of b over a plus 2 pi when angle is in the fourth quadrant. All right, so that's how you find alpha. All right, so here are some terminology. All right, so here we have C. All right, this guy is called the amplitude. All right, because this is going to be the cosine curve, so it's going to go up and down, up and down. That C value determines the amplitude of that cosine curve. All right, and alpha is called the phase angle. This guy is called the phase angle. All right, and omega here is called the circular frequency. Right, and there are a couple more terminology, and one's called period. All right, and the period they're going to use capital T is just simply 2 pi over omega, right? Because it's if omega is 1, then the normal period of the cosine curve would be 2 pi, all right? And it's called a time lag. So maybe it might make sense to, if you rewrite that equation as say so x of t as c times cosine, then if you pull out the omega, then you have a t minus alpha over omega, right? All right, and this guy is called time lag, because this is really a shifting along the t-axis. So this is called the time lag. Right? So those are just the terminology. But for free undamped motion, we use the characteristic equation, and we solve for the solution, and then we can manipulate the solution so that it looks like a cosine curve. All right, that's it. I hope that this was clear.